Okay, today I'll take mode. Mode is not for your syllabus, only for the sake of future reference. Mode is essential in the future chapters. Therefore, I'll take the mode today for a future reference. Okay. So mode is also an average, means of central tendency. Then what is mode? The mode is the value which has the highest frequency. Mode is nothing but which has the highest frequency or which occurs again and again, which occurs maximum times. Which value occurs maximum time, that is called as mode. Mode is a value which has the highest frequency. Means if the values are given for you for the calculation of mode, then which value appears highest number, that value is called as mode. That value is called as mode. Okay, and it is denoted by Z. It is denoted by Z. Mode is a simple one. Among the given values, which value appeared highest time, that is the mode. Okay. Then first, how to calculate mode for raw data or ungrouped data. Okay, for example, the value which repeats maximum is called mode. Among the values, which value repeat for the raw data or for the raw data, if numbers are given, if you want to calculate mode, so the value which repeated maximum times is called as mode. Okay. So here is the example. Here is the example, and answer is also given here. You see the number 2, 3, 6, 2, 3, 4, 0, 5, 2, 2, 4, 3, 2, 1, 0, 4, 2, 2, 1, 1, 3. This is the question. Answer part is next. Okay. Then among these value, which number appeared maximum time? You have to see. For this, you have to draw the table or count the numbers, or you write the sequence wise. How many twos are there? How many ones are there? How many zeros are there? So you count the numbers. Okay, you count the numbers. Among all these value, if you count the zeros, I think in this problem, I'll count the zeros first. You see here. How many zeros are there? 1 0, 2 0. Only 2 zeros are there. 0 is equal to 2. Okay. Then if you come to ones, how many ones are there? This is 1, this is 2, this is 3. Only 1 is equal to 3. 3 ones are there. Then come to twos. This is 1, 2, 3, 4, 5, 6. Now twos are 6. Okay, come to 3. How many 3s are there? 1, 2, 3, 4. There are 4 3s. Come to 4. 4, 1, 2, 3. 4s are 3. Then 5 number. Come to 5. 5s are 1. Only 5 is there. Only one 5 is there. Is there any other numbers? No. So out of these, there are 2 zeros, 1 number 3, 2 number 6, 3 number 4, 4 number 3, 5 number 1. Therefore, maximum times the 2 is repeated. Therefore, mode is 2. In this way, you have to calculate. This is called as mode for the ungrouped data. This question may come for 2 marks. Okay. So mode is 2. This is calculation of mode for the ungrouped data. Only numbers are given. Okay. Next is mode for grouped data. If the information is grouped in the group, then how to calculate mode? So if the group data is there, under that discrete series, if the series is a discrete series, then the value of mode, the value related with highest frequency is called mode. You have to observe the frequency column. In the frequency column, which is the highest frequency, and related value to that frequency is called as mode. You see the example. Calculation of mode. Calculate mode for the following data. This is the discrete frequency distribution. Rent is there, number of families are there. Then you see the rent value is called a S column, value column. Family is called as frequency. In the frequency, what is the highest frequency? This 88 is not highest. This is the total. You have to accept this total. Don't consider this total. Leaving the total out of remaining frequency, which is the highest. Among these frequencies, the highest frequency is 25. Okay. 25 is the highest frequency. Highest frequency is 25. And related value to this is 1700. This 1700 is called as mode. 1700 is called as mode. Therefore, mode is equal to 1700. In this way, you calculate mode for the frequency distribution, discrete frequency distribution. Okay. This is the second method. First method, only numbers are given. You see which number appeared maximum time, that is the mode. Okay. Then if Whatever message you put in the chat box, that will be served to all the members. Remember this. Okay, this is the mode. First method for values, second for discrete frequency distribution. Second method is for discrete frequency distribution. Then come to the continuous frequency distribution. How to calculate mode for continuous frequency distribution? Okay, mode for continuous frequency distribution. Mode for continuous frequency distribution, exclusive class. If the class is given in the exclusive way, how to calculate mode? How to calculate mode? First, you see the highest frequency in the frequency column. Highest frequency, see the frequency, and highest frequency related class is called as model class. Model class, and apply the equation. Then apply the equation. 3 steps. One step, you find the highest frequency in the frequency column. Then consider related class as model class. And thirdly, apply the equation. 3 steps. Okay, select the model class based on highest frequency. Then next, apply the equation. Apply the equation. This is the equation. Z is equal to L, means lower limit. L is the lower limit, plus F minus F1. F minus F1 into C means class interval. F means frequency related with the model class. Minus F1 means frequency related with the previous class. Then C is the class interval. C is the class interval. 2F means you multiply the frequency by 2. Minus F1 means frequency related with previous class. Minus F2 means frequency related with succeeding class, next class. You see here. L means lower limit of the model class. Then next, F means frequency of the model class. Then next is C. F1 means frequency of the class preceding to model class, means previous class. Then F2 is the frequency of the class succeeding the model class, means next class. And C is the class interval. Okay. With this, you have to solve the problem. Okay, you see one example. Find the mode for the following frequency distribution. Mode for the following frequency distribution. Okay, you see here. Wage rate is given below 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 and above. Okay, this is the given information. This is the given information. Then first step, you have to find the highest frequency. Which is the highest frequency? In the given frequencies, highest frequency is 34. Highest frequency is 34. Okay. Highest frequency in the frequency workers is 34. This is the highest frequency. Okay. And this class is called as model class. This is called as model class. First you select it. Highest frequency related class is called as model class. And to this, you have to apply the equation. And this is called as F1. And F, this is called as F. And this is called as F2. Remember this. Before the model class, F1. After the model class, F2. And middle is F. Okay. And class interval you have to see, lower limit you have to see. Okay. First you select the class. Now apply the equation. Okay. Model class is 50 to 60. Then apply the equation. Z is equal to L plus F minus F1 into C divided by 2F minus F2, F1 minus F2. Okay, if you fill the values, F1 minus F minus F1, F is 34, this 34, and F1 is 29 before this. This is the F1 29 into 10 class interval 10 to 50 to 60. Difference is 10. That is class interval divided by 2F. 2F means F is 34. Multiply by 2. You put a bracket for this. And minus F1. F1 is 29. Minus 29. And F2 is minus 12. You put the values like this. Okay. The next step. Z is equal to lower limit is 50. 34 minus 29 is equal to 5 into 10. Numerator place. 2 into 34 is equal to 68 minus 29 minus 12. Okay. Then next, Z is equal to 50 plus 5 into 10, 50 divided by 68 minus 29 minus 12. 27. Okay, 27. Then next, Z is equal to 50 plus 1.85. Z is equal to 1 plus Z is equal to 51.85. Answer. In this way, calculate the Z value. You calculate the Z value. Okay. Z means mode. This is the method of calculation of mode for exclusive class. Exclusive class. Now I'll take one example based on inclusive class. How to calculate mode for the inclusive class. Mode for continuous frequency distribution inclusive class. Okay. Here also you have to find the model class based on highest frequency. Then you have to change the class into exclusive class. Change the class into exclusive value. Okay. So select the model class based on highest frequency. Then next, convert the lower limit values. Convert the lower limit and upper limit values. You may convert for only class also. Okay. And then third step, apply the equation. This is the equation. This is the equation. Then I will take one example. You see the example, compute the mode for the following data. Class 40 to 49, 49 to 59, 59 to 50, 60 to 69. This is the class because lower limit of the first class is not the upper limit of second class. In this case, you have to convert the class first. Okay, you prepare the frequency distribution table. This is the frequency distribution table. Frequency distribution table. First, you write the class. This is the class. Okay. You may convert the required one or you may convert the all the classes. I will convert all the class. Frequency is 4, 6, 10, 50, 18, 9, 3. Total 50 is the frequency. Okay. Total 50 is the frequency. Then you have to calculate. You have to find the highest frequency. Highest frequency is 18. Okay. 18 is the highest frequency. Related to this is 79. 79 to, you see this. 70 to 79 is the class, but it is not the class for model because the class is inclusive class. You have to convert this into exclusive. You may convert this 70 only. and solve the problem, no problem. You may convert only this class into exclusive. 69 plus 79. 69 plus 79, 139. 139 divided by 2, 69.5. 69.5. You may take that 69.5 here. 69.5 L value. Okay, you can directly solve the problem. By taking 69.5 as the lower limit, you can solve the problem. You will save the time. If it is confusing, you prepare the class. This is the class. You prepare the exclusive class. 39.5 to 49.5. It is 49 plus 51. Sorry, 99.99. 99 divided by 2 is equal to 49.5. So 0.5 increase, 0.5 decrease. 0.5 increase in the upper limit, 0.5 decrease in the lower limit, and prepare the class. These are the class. Okay. So 69.5 is your lower limit. Then write the equation. Equation is Z is equal to L plus F minus F1 into C divided by 2F2 2F2 minus F1 minus F2. Okay. If you fill the values, 69.5 is the lower limit, plus 18 is the F value. F1 is 10. This is F1. Okay. You can mark this. With the pen, you can mark this is F, this is F1, and this 9 is F2. Okay. Like this, you can mark and fill the values. 18 minus 10. F is 18, F1 is 10. Into 10 is the class interval. Divided by 2 into 18 minus 10 minus 9. Okay. In the next step, you write the value. Z is equal to 69.5. 18 minus 10, 8 into 10. 2 into 18, 36. Minus 19. 10 minus 9. Totally minus is 19. Like this you may write. So next step, 69.5 into 80 divided by 17. 80 divided by 17. Okay. 80 divided by 17 is equal to 69.5 plus 4.7. The answer is 74.2. 74.2 is the mode. Okay, in this way you have to calculate the mode for inclusive class. This is the basic theory regarding mode, and mode cannot be calculated if there are two maximum values. If there are two maximum frequency value, it is not possible to calculate with the help of equation. Okay. And in the next class, I will take the dispersion parts. This is not for your syllabus. For your reference purpose, I have explained all these things, and you go through the examples. Okay. Tomorrow also at 4 o'clock, I'll engage your class. Again, tomorrow.